So, you're gearing up for the IGCSE physics exam and paper 6 is on your mind. It can feel a little tricky, but honestly, don't worry. In this explainer, we are going to break down the exact strategies you need to absolutely master it and lock in those crucial marks.
We're going to cover 3 key areas where students, sometimes lose marks: taking measurements, drawing graphs, and of course, planning those experiments. By the end of this, you'll know exactly what the examiners are looking for. So, let's get started.
All right, first up, let's tackle one of the most common points of confusion: decimal places versus significant figures. Getting this right is such a simple way to make sure you're not just throwing away easy marks.
So, how do you know which one to use? Well, it all comes down to a really simple question. Are you measuring something directly from a tool, or are you doing a calculation? Let's look at the rule for each one. The rule for decimal places is super simple. For any direct measurement you take from an instrument, you use decimal places. Your answer has to match the precision of that tool. So, if a thermometer is marked in whole degrees, you write down a whole number, like 23 degrees Celsius. If your ruler has millimeters, you record to the nearest millimeter. You're literally just writing down what you see. Okay, so what about significant figures? Well, this is the rule you use anytime you pick up your calculator. When you calculate something using numbers you've measured, your final answer can't possibly be more precise than your least precise measurement, right? It's all about being honest about your equipment. You can't just magically create extra precision in a calculation. Let's look at a classic example: calculating resistance using the formula R equals V over I. You've gone and measured your voltage and your current, and now you need to figure out the resistance. Let's walk through this step by step. First thing you do, identify the significant figures in your raw data. Our voltage, 3.6, well, that has 2 sig figs. Our current, 0.81, also has 2. So the lowest number of sig figs we're working with here is 2. Next, you do the calculation. 3.6 divided by 0.81 gives you this long decimal on your calculator. And finally, and this is the most important step, you round your answer to match that lowest number of significant figures, which we already said was 2. And that gives us our final answer, 4.4 ohms. See? By following that one simple rule, you've shown the examiner you understand precision, and you've just bagged the mark. Easy.
Okay, let's move on to our next big topic: graphs. This is a section where marks are pretty much guaranteed if you just follow a few simple golden rules.
Don't think of these as suggestions. Think of them as your checklist for getting full marks. First, use a large scale. It has to fill at least half the graph paper. Second, label both your axes with the quantity and its unit. Third, plot your points as precisely as you possibly can. And finally, draw a single thin line of best fit. No sketching, okay? One clean line. A lot of the time, you'll be asked to calculate the gradient of your best fit line. And for that, you'll use this familiar formula: rise over run, or the change in y divided by the change in x. Now, here is the most important tip for calculating that gradient. Your triangle must be large. I mean it. It needs to cover at least half the length of your line. So why is this so important? Well, a big triangle minimizes any little reading errors, and it proves to the examiner that your calculation is based on the overall trend of your graph, not just 2 random points that happen to be close together. Okay, time to tackle the final beast, the experiment planning question. I know this is often the part of paper 6 that students fear the most, but trust me, with a clear structure, you can absolutely conquer it. That's right, 7 marks. This one question is worth a huge chunk of your grade, so paying really close attention to the details here is absolutely essential. So, where do you even begin? My number 1 tip is this: always start by drawing the diagram. Don't even think about writing a single word yet. Drawing the setup first forces you to visualize the entire experiment, and that makes writing the step-by-step method so much easier. Once your diagram is done, your method pretty much writes itself. You just describe what you drew. Step 1, set up the apparatus just like in the diagram. Step 2, measure your first variable, u, with a meter rule. Step 3, adjust the screen until the image is perfectly sharp. Step 4, measure your second variable, v. And the crucial final step, step 5, state that you will repeat the whole thing for different values of u to get a good range of results. The question will also ask for precautions, and it's a great idea to split these into 2 categories in your head. First, how do you get a good quality result? For an experiment with a lens, this means working in a dark room so other light doesn't interfere, and making sure all your equipment is lined up perfectly in a straight line. The second set of precautions is all about the accuracy of your measurements. To avoid parallax error, when the reading looks different from different angles, always position your eye directly perpendicular to the scale. To make your results more reliable, repeat each measurement and then calculate an average. And finally, using a white screen actually helps you judge the sharpness of the image more clearly. Wow, we've covered a lot. So let's boil it all down to the most critical takeaways that you need to remember as you walk into that exam hall.
Here is your final checklist. Number 1. For measurements, just remember instruments mean decimal places and calculators mean significant figures. 2. For graphs, make that gradient triangle absolutely massive. And 3. For that big 7-mark question, always, always, always draw the diagram before you write a single word of your method.
And that's it. You now have a clear, simple toolkit for tackling the trickiest parts of Paper 6. Take a deep breath, trust in all the preparation you've done, and go show them what you know. You've totally got this. Fundoo Tutor is a personalized learning platform that helps students succeed in Cambridge, IB, and other international curriculums with expert mentorship, structured learning support, and engaging resources.